here was at my other talk earlier? I was like, a few people, cool. Also, I didn't realize the other room was like the bigger room, so this is going to be like maybe more of a conversation if I can get the talk to be like that. Yeah, who here has heard a similar talk from me before? Like this talk is based on talks I gave last year. No? Okay, cool. Okay, then it's pretty new for you. That's amazing. So basically, whenever I give a talk, I kind of rewrite it for the conference. So even if you've heard similar content from me before, this should be a little bit different. Who here is based in Berlin or from Berlin? Hands up. Nobody. Somebody? One person? Okay, everybody else is from around the place. Germany. Someone else in Germany. Okay. Okay, cool. Yeah, so I actually used to live in Berlin. Berlin is kind of my pandemic city, I call it, because I used to live here during most of COVID. And then I had enough, so I moved. But that was also the time when I got started in the cloud-native ecosystem. Before that, I was working in a different tech industry, in the blockchain crypto space, which Berlin is really popular for as well. You have lots of startups here, or you had lots of startups here for that space as well. So then I moved to a company called CodeFresh that's working with CI/CD platforms, and that's when I gave my first talk on Argo CD. And at the time, I was learning about containers and about Kubernetes. That was like about 3 years ago nearly. And I thought Argo CD is what everybody uses, right? Because I had no clue what people were actually doing. So from my perspective, Argo CD was what people were using. And that was my first online webinar that I was giving. And you can see here like my setup at the time. Anyway, this talk is really about site reliability engineering and the combination with cloud-native security, and why I think that specifically within SRE and the SRE space and observability space, it's really easy to integrate our security tooling. That's kind of what I'm trying to advocate for. Because, so after my first job, where you saw the screenshot for, or like the photo of, I moved to work for a startup in the UK as SRE for about 9 months, and then I joined at the beginning of 2022 Accra Security. Now the thing is that when I was working as SRE, it was like a smaller startup, and it's called Sivo, and we basically provide an infrastructure where you can spin up Kubernetes clusters, and as well as tenant clusters on our large-scale superclusters. So there's a screenshot from a KubeCon talk that I gave with a colleague manager at the time, and basically we were detailing our infrastructure on how we set up our observability stack. So if you're curious, there's the talk or the link to the talk that you can check out later. But basically what I want to get to is that we talked really comprehensively on how we set up our observability tooling, how we set up Thanos, Prometheus, Grafana, Loki, everything, all the nice stuff. But we didn't talk specifically about security tooling, and we didn't, while we implemented security best practices, we didn't in particular talk about the security tooling that we were using, and we weren't actually on a day-to-day basis. We weren't using specific security tooling. So then when I joined Accra Security, I was like, this is actually quite easy to implement. So why are not more people doing that, right? As a developer advocate, you're always kind of in the state where you always get like one side of the story mostly, and then not like the other side. So why are people not implementing it? Why didn't we implement it if it's actually not that difficult to do? Well, that leads to people not implementing security scanners, such as misconfiguration scanner, can lead to lots of exposed data, exposed information, specifically for misconfiguration scans. So here's some data that I also showed in the talk earlier that I like to share, which is basically a huge table, if you check it out on GitHub, of 2021 data of exposed, issues in different configurations, different cloud services that expose data. And there are really things that could have been prevented. And it's not, from my perspective, it's not on the security team to prevent it, but on the organization, for engineers, infrastructure engineers, DevOps engineers, to implement best practices to counteract potential data loss and exposing data. Now, I came across this tweet by a technical product manager for, I think she's working for a security company, and she's basically saying that reality is that business will push to get the update into production, and InfoSec will pray that the vulnerability doesn't get exploited. That's why defense and dev is so critical for containers. Who has had been in that position before, where one team just wanted to push a feature, wanted to deploy it, wanted to get it done, go home, and then you have like the security team who's kind of putting a break, a stop in. Is that something people here, okay, somebody experience? Yeah? Okay, so it's kind of the story that's being told a lot, like whose responsibility is it? Whose responsibility is it to implement the update to the library, to fix, to not have the CVE within and similar, right? Like there's kind of this, I guess, and clarity a lot of times, especially within smaller teams, when you don't have a dedicated security team, like who is actually supposed to do it in that case as well. So why am I standing here and saying that I think it's that security and SRE, is that reliability engineering, go hand in hand? Well, within your SRE culture, you work towards a lot of qualities, I guess I would say, within your team that allow you to easily also integrate security solutions. So for example, when we're talking about within the SRE culture about creating autonomous teams, building the workflows as such that people are empowered to implement updates, then we can easily also talk about, okay, how can we build our workflows as such that people can be ensured that what they're deploying is meeting our security standards, so they don't have to second guess it or just try to look away. Also within the SRE culture, we're talking a lot about analyzing learnings, like our failures basically, and trying to learn from them as part of postmortems. That's something that has to be, I guess, become more structured within the security space, that we actually look at what's going right and what's going wrong within our security-related stack components, and then learn from whatever is going wrong, ideally before it goes wrong or publicly. So also within the SRE culture, basically, or the premise of this talk is that if we focus on the intersection between SRE practice and security practices, we can make our lives a lot easier, because if we implement, for example, security scanning early on into our stack, then we can ensure that any security issues can be addressed, or that we have the information to address them, to make the decision to address them early on. Also, within SRE practices, we talk a lot about what do healthy services look like to us? How we define like how services are supposed to scale over time. When we talk about these kind of qualities, we also have to talk about in a way of what secure services look like. From my perspective, a service is not healthy if it's not also secure. It goes hand in hand. The thing is that we can deploy our application, we can deploy our microservices, as long as they are working, whether or not they are secure. Now, if they don't work, then we can't deploy them. But for the security perspective, there can be security issues within. As long as it works, we can still ship it, which is kind of an issue. So here's some other specific goals that we can work towards, both from a security perspective as well as an SRE perspective. We want to, for example, visualize our metrics within the SRE space. So we want to get visibility insights into our different services, our components, the behavior, how they perform over time with different loads and similar. And we can do that also from a SRE perspective. From a security perspective, that we can visualize our security metrics as well to give people a better idea of where, for example, their new deployments, their new features perform in what area. So this is a screenshot that's taken from, or like visualizing the metrics from a Trivy operator, which is a Kubernetes operator that's running within your cluster. And you can visualize, similar to how you visualize other metrics, showcase, for example, how many vulnerabilities do you have across your cluster. And that gives you an idea over time, like how does your cluster evolve from a security standpoint, similar with misconfigurations. Now, if there are critical vulnerabilities, critical misconfigurations, you will likely want to take a look at that, or even set up alerts through your monitoring stack on new critical issues that are within your environments. Similarly, when we talk about automation from an SRE perspective, in the SRE space, for example, we want to build robust automation that allow people to test their their components, their new tooling, and be basically self-sufficient. From a security perspective, when we set up our automation pipelines, we can also then build in our security tooling within our automation pipelines. So for instance, to give you an example, the first day that I was working as SRE, I basically deleted all of the services that we had in our staging environment, because I was able to manually make edits to our staging environment. Everything was just gone, and I didn't really realize that that was me who deleted everything. So subsequently, we built our pipelines as such that I couldn't just go there and delete, for example, all of the services in our production environment, right? So we learned from that incident. Similarly, what we could do is to implement security scanning and other security measures that I can't just go there and deploy a service that has critical misconfigurations. So we want to build robust delivery pipelines, and that starts before we actually think about the deployment process, like before we actually have kind of our built a container image and then deploy it. And I talked about it earlier in the talk as well about a lot, so I'm not going to go into more detail or into much detail. Now, a deployment pipeline can actually also automate all of your scanning processes. For example, in the case of security scanning, so you can scan your file system, you can package your container image, scan the container image for vulnerabilities. You can then, in this case, upload any security issues also to any software that you're using to manage security issues. For example, if you're using GitHub native one, you could upload it to the GitHub security tab. So you can really integrate or like automate security scanning. Now the thing is with automation, what I mentioned earlier, when we talk about the security from a security perspective, if there are critical issues, as long as people can access and use your application, they won't know if there are critical security issues within an application until it's too late. So you can still go ahead, even if there are critical issues in the pipeline found, or like through the scanning in the pipeline found, you can still go ahead and deploy it. If the application is not working as expected and people can't access it, then you wouldn't be able to deploy it. So when you're thinking about automation from a security perspective, you have to think also about the different edge cases that you don't necessarily have to think about when you're talking about like automation from the deployment perspective, solely from the deployment perspective. Now we want to implement as much security scanning and similar, or like security tooling as possible to discover issues as early as possible, because the longer we wait, the more complex those issues will become and the more difficult it will be to fix them. Now, another big thing is what I mentioned, I think I mentioned earlier, or maybe in the other talk, is scalability. So when we define how our processes, our deployments are supposed to evolve and scale over time, we also have to talk about how do we keep them secure over time. Whether that's like, we talked over lunch with somebody who told us about a story where somebody was manually scaling their services. When we talk about that, like if you manually upscale your services versus when you automate that process, you still have to think about the different security implications of both. And then we want to gain a common understanding how our services should or should not be used as more and more people, for example, access it. So as you have different teams, for example, more teams using your tooling, setting up their own deployment pipelines of different components of the stack, you want to gain kind of a common understanding of who's supposed to do what and when. Don't have a time here. Oh, there's a time. Never mind. Okay. Cool. Then something else that's big in the SRE space is reducing noise and toil. So you don't want to be bombarded with information. That's kind of the goal, that you only get access to or like presented with meaningful information on a regular basis. Now, here's a screenshot of a container image scan that has over 750 different vulnerabilities. And nobody's going to look at each of those vulnerabilities. Nobody's going to take the time to go through it. So that's ultimately, if you present with that kind of information, that's noise to you because you can't perform any actionable items on that information. There are over 700 different vulnerabilities in that container image. Like, what are you supposed to do if you still want to use that container image? What you can do instead is you can filter the information that you're presented with in a more meaningful way, something that allows you to take actions upon. So now that we know that security is a a great thing and we want to actually get started with implementing security solutions into our stack. Maybe we are like an infrastructure engineer and we want to make our pipelines more security-centric, more security-focused. How do we get started ultimately? The following slides are based on Trivy, but this is not a Trivy presentation. So if you are curious about Trivy, here's more information on their GitHub repository and like the different, some of the different features of Trivy. Anyway, so first step, you need to understand your needs. Everybody's needs will be different. Your needs on what kind of security tooling you might want to use will depend on different factors. For example, the size of your team, the resources that you have access to, for example, budget and expertise. Do you want to build an in-house tool? Do you want to use an open source tool? Do you want to outsource it and pay a SaaS business and invest in that? And it's a managed security tooling. What kind of industry you're working with, it will be quite different if you're working in a highly regulated industry such as banking versus you're in a small startup that might not require the same types of compliance reports. Then you want to also consider your existing stack. How much do you want to integrate new tooling, security tooling into your existing stack? How much is one dependent on the other? Also, is security tooling and like shifting towards a more security-centric mindset, is it supported by your company goals and the leadership, or is it not? That's something that will play different roles, or like will be important to different extent depending on where you work and how you work. So one of those factors might matter more to you than the other. And the next step is to understand the different scanners, for example, the different security scanners that are available to you. They will all differ in different ways. Now, I'm not going to go into too much detail into this slide because I spoke about it in the other presentation as well. But ultimately, these are the main 5 factors in which security scanners, for example, will differ in the space in terms of installation. How do you install it? How do you use it? If you want your engineers to use a security scanner, for example, for their file systems, for any libraries they are using, you will want to look at different types of tooling than if you want to have your cluster administrators to monitor the state of the cluster over time. Scan coverage, what types of scans can a security scanner, for example, or can the security tool perform? What can it work with? There are different types of scanner that will focus on different resources. If you're working heavily with Helm, for example, you want to have a scanner that can understand Helm charts and then interpret Helm charts and scan them for misconfiguration issues. Resource types that the scanner works with, or the security tooling works with. There are different security tooling that you install within your cluster, and they will use different Kubernetes resources, for example, to work and to access your other resources, the state of your cluster. Integrations, again, this is like depending on whom you want to actually, within your team, use that tool, you want to make sure that you can integrate new tooling with your existing workflows. And then the focus on like audience focus, like different tools are focused on different user groups. You will find some tools, security tools that are heavily focused towards the pen testing area, versus other tools are more focused on cluster admins or engineers to scan their resources. Next, you want to choose a security scanner, for example, or if you're talking about other types of tooling, security tooling, there are different options available, lots of different options available. So you want to go through them and test them out and develop proof of concepts over time, basically, or like, not over time, but yeah, basically understand the differences between the different tooling to ensure that you're choosing the right one for you, for your team, depending on what you want to solve. Proof of concept is really important. Like I mentioned, you will all have different workflows. You will work with different types of resources. Some of you might work more with Terraform. Others will use more projects, for example, within the CNCF space that have lots of CRDs, custom resource definitions that you have to work with. One limitation of most security scanners is that they can't scan custom resources yet. You would have to write custom policies. So you want to understand, can you write custom policies for your, for example, Argo CD resources? Do you have the expertise in your team? Do people within your team understand Rego policies and know how to write Rego policies to scan those custom resources? These are all questions that you will be confronted with. Might be confronted with. So you want to identify the best installation options for the security scanner as well, or like for the security tooling as well, and then how you want to configure that security scanner, and that refers, for example, to the additional policies that you want to set up for your security scanning or for your policies. And then you want to test those custom configurations. That's something that's really important, which we don't do, from my perspective, enough when working with, for example, open source security scanners. Last year I gave several times, also early this year, a talk about using chaos engineering for security purposes. So a lot of times we set up, for example, security scanners, misconfiguration scanners that are supposed to identify misconfigurations in our cluster, but we don't verify that they are actually going to verify it the way that we set it up. So we set up a policy, and then we expect that policy to work, but we don't verify it additional against edge cases and different scenarios. So that's something important. So you, for example, notified if there's a new critical vulnerability within your cluster, you want to get notified, and you want to kind of have the confidence that your security tooling will notify you. And then you want to ensure that everything is working correctly. Now, you might have a different stack, or a completely different stack. And again, different security tooling will be able to work with different stacks or not, right? So for example, newer tooling such as Crossplane. Who has used Crossplane before? Two hands, cool. It's a CNCF project, and it's fairly new in the way that it's handling setting up resources. And for example, security scanners can't scan it. They can't scan their custom resources by default. So you want to kind of keep that in mind of like how your existing tooling with new security tooling will integrate, and maybe your new tooling or like using fancy new technologies will actually prevent you from increasing the scan coverage and keeping your infrastructure secure over time. Then the next thing is team education, which is kind of a lot of times not talked about that much within the security space. So it doesn't really help if you have a fancy UI that's giving you all the data that you could wish for, if then people don't know what to do with that information, right? So a lot of times people will, for example, use security scanning, vulnerability scanning. There's vulnerability scanners also now provided out of the box with Docker. The thing is, it's really about what you then do with that information. How do you handle that information long term? So that might require you to provide the resources, the time for people to understand what to do with this tooling, with this new information. It might be about dividing responsibilities and ownership of the different tooling that you implement, as well as existing tooling from a security perspective. Then you also want to build, like I mentioned earlier, your ICD, your dashboards, alerts, similar around the security tooling that you set up. So for example, if you're using GitHub Actions, you would want to expand it to also implement or like to integrate with the other components that you have access to, such as GitHub is providing a security tab where you can kind of track the different misconfigurations, vulnerabilities directly in GitHub. So you might want to make use of these existing dashboards. If you're using Grafana, again, you might want to then invest in setting up custom dashboards that are meaningful for you and your team. Correlating metrics is another thing that then becomes really handy. Like instead of using completely separate dashboards, what you can do is to set your dashboards up in such a way that you can correlate the metrics. So if something, for example, you see, or like the person who's responsible to look at the number of vulnerabilities and track the vulnerabilities across your services realizes that there's an unusual amount of new vulnerabilities, to be able to correlate it with other events within your cluster. Now that also relates with other practices such as GitOps, knowing when things get deployed, where they get deployed, how they get deployed, being able to gather that information easily from like also an infrastructure perspective will make it easier to apply additional security measures. Either automate and educate. Now, what do I mean by that? If you can't automate things, so if it doesn't make sense for you to automate something, then educating, for example, somebody more junior in the team on how to do things manually can be very beneficial. In getting fixed done. So instead of like, a lot of times I think within the security scanning space especially, things are not really automated within the pipeline. But if you don't want to like provide the scanning automatically within the pipeline and set up the additional processes to follow up on those scans, then maybe making it somebody else's responsibility on a day-to-day basis to check through those scans might be more helpful. Then don't stop at security scanning. I gave security scanning as an example. There are lots of security-related projects that are evolving more and more over time. For example, in the CNCF space, such as Sigstore. Who has used Sigstore Cosine before? Okay, a few people. So basically, Zigstore allows you, is a popular project that allows you to sign artifacts to basically say, yeah, this container image was created by our company. And then people can verify that that container image was actually created by your company, and that's related to more securing the software supply chain. And making sure that people can't tamper with the resources, or less like to tamper with the resources. Then Kyriano is within the CNCF and providing policies that you can set up within your cluster as Kubernetes resources. So you can basically specify policies that are meaningful to your and your organization to track events that might have passed, for example, the measurements that you took in your pipeline. And then the last thing is, yeah, keep iterating on your existing tooling. A lot of times we set things up, and then also shiny new technologies, we set them up, and then we kind of leave them there, and we don't do much with it, which is not the best approach over time. As these tools, most of the tools within the CNCF, and many open source tools, they change a lot over time, right? So we want to keep evolving them. Now, if you want to have more information, I have a YouTube channel where I talk about these things, where I provide from time to time longer tutorials as well. And then we also have, it's part of Aqua, the Aqua open source channel, where we talk a lot about Trivy and Kubernetes operator to do scans, to perform scans. And then I also have a weekly DevOps newsletter where I share just interesting technologies, projects that I come across. So do check that out if you're interested. And here's some additional resources. Yeah. Cool, thank you. Any questions? Any questions? Any thoughts? Any? Yeah, there.
Do you have tips or tricks how to educate? You know, I work as a consultant, so I'm mostly the external guy. And any tips on educating customers, which might be aware of security, but do not implement it or do not look at the dashboards?
Yeah, you can't make them, right? And I think even what I mentioned earlier, right? Like that we all know what can go wrong if we have certain misconfigurations. But I think it's one of those things that's like smoking, you know? I don't want to offend any smokers here, but we know what can go wrong, right? But we still don't, I guess, take misconfigurations as seriously as they should be taken. So, and it's actually, the thing is, or like what I think is better to show people how easy it is to actually use, for example, secure misconfiguration scanners. That it's not that difficult, and you kind of need from the leadership team though the buy-in to provide the time, the additional time that it takes, right? Because if you're busy fixing a bug and then having to put security scanning or like taking care of those measures on top of it, you might not want to do that, right? Like you might just ignore it, as you mentioned. Like the tooling might be set up, but you're just not going to look at it because there's not the dedicated time for you to do so. So in that case, maybe like assigning ownership of specific resources to specific people. Whether they look at it or not, that's then on them to some extent, but at least you say, okay, you are responsible for XYZ resources. You can decide how often you look at it, but if we check once a month, and we see that the services you are responsible for have a above average number of vulnerabilities, then we want to have an explanation why that is the case, right? That could be one approach. I mean, I'm curious to hear about other approaches, but yeah, good question.
Are there any more questions?
Hi, my name is Anton, and I didn't understand everything about the project. Does it provide URL scanning? So is it possible to, what kind of vulnerabilities it scan for?
You mean Trivy specifically?
Yes.
So, let me find a slide. Yeah, I mean, so this talk really didn't go into detail of Trivy, just used kind of security scanning as an example for implementing security tooling, and Trivy specifically because I work at Aqua and Trivy is our open source security scanner there. But basically with Trivy you have 4 different types of scanners: vulnerability scanners, which can scan your file system and the libraries within that you use, as well as container images and similar for vulnerabilities that are found in the libraries that you're using within your code, for example. So it really depends on which language you're using on how it will scan those files for vulnerabilities and where we'll get the information from. But ultimately, it can, for vulnerabilities, it can scan different scan targets, such as container images, one scan targets for vulnerabilities, and then display them as like a list of like, here are all the vulnerabilities that are identified. Does that answer the question?
Got it.
Awesome. Thank you.
Okay, thank you very much for the answers and questions and for your nice talk.